21C, number 1, the answers are either box or draws. Probabilities are used when reasoning from the box to the draws. So for probabilities, you know what you expect to happen, so you're going to guess what will happen when you roll the dice or play roulette. So that uses a box to predict what the draws will be. Confidence levels are used when reasoning from the draws to the box. When do we use confidence intervals? Well, I mean, yes, but we'd probably explain that in a different way. What do confidence intervals do for us? They provide us with information about what is in the box. Right? We don't know what's in the box, and usually we don't even know how many people are in the box. If we knew both of those, then we wouldn't be using confidence intervals. Okay, number 2. The chance error is in the observed value, not expected. The confidence interval is for the population percentage. The sample percentage is sort of the old expected value, but we call it observed value. And a confidence interval describes what we think happens in a population. Okay, number 4. A box contains a large number of red and blue marbles. The proportion of red marbles is known to be 50%. A sample percentage of 100 marbles is drawn from the box. Say whether each of the following statements is true or false and explain. The percentage of red marbles in the sample has an expected value of 50% and a standard error of 5%. True or false? True. Why? We are reasoning from the box to the draws, so we're going to predict using probability what's going to happen. So we have a 68% probability of getting 50% red in our sample, plus or minus 5%. Okay, B, the 5% measures the likely size of the chance error in the 50%. True or false? The 5% measures the likely size of the chance error in the 50%. False. Why? So what page are the answers on? I'll read it to you. So 20. So B, the expected value is computed exactly. The chance error is in the sample percentage of reds, not the expected value of reds. The expected value is 50. Okay, the chance error is in the sample percentage. Does that make sense? So what they asked was the 5% measures the likely size of the chance error in the 50%. Well, the 50% is just what's expected. So that 5% is in the expected, or sorry, I just said it wrong, in the sample percentage. The expected value is exactly what's in the box. Okay, C. The percentage of the reds in the sample will be around 50%, give or take 5% or so. Yeah, that's the probability, right? I'm going to double check that. C says true. Wonderful. D. An approximate 95% confidence interval for the percentage of reds in the sample is 40 to 60%. Can we use confidence intervals? No. Confidence intervals describe what we think is in the box. Well, we know what's in the box. So we have to do probability methods, not confidence intervals. So false, there is no confidence interval here. And E, there is a 95% chance that the percentage of reds in the sample will be in the range from 40% to 60%. True, that's 2 standard errors. That is a probability question. It's not a confidence interval. It's not, we're 95% sure. It just means 95% of the time it will be in that window. Does that understand? So a confidence interval says, we think we're 95% sure that this is what happened in the box. That's used when you take a sample. If you know the population and you're going to create a sample using that population, you don't use confidence intervals, you use probability. There's a 95% chance that the answers will be between 40 and 60. Now that sounds like the same thing, but it's not. Okay, confidence intervals just means how confident you are, and then probabilities mean this is what will happen when we take the sample. Okay, number 7. How about number 6? A simple random sample of 1,000 persons is taken to estimate the percentage of Democrats in a large population. It turns out that 543 of the people in the sample are Democrats. True, false, and explain. The sample percentage is 45.3, and the SE is 1.6. Well, 54.3 is certainly correct. To find the standard error, we have to do the square root of 54.3, or sorry, that's not what I meant. 0.453 times 0.457. Do those add up to 100? Yes. Okay. This is the SD, and now I need to divide it by, how do I find the standard error for percentage? Square root of 1,000. And I get 1.6. So 54.3 plus or minus 1.6. Okay, that's true. 54.3 plus or minus 3.2 is a 95% confidence interval for the population percentage. True. 54.3 plus or minus 3.2 is a 95% confidence interval for the sample percentage. False. What is the sample percentage? It's 54.3, right? How sure are we that that is the sample percentage? 100% sure. That's what we got, right? So a confidence interval does not describe the sample. You know what's in the sample, and you use that information to try to figure out what's in the population. So C is false. There is a 95% chance for the percentage of Democrats in the population to be in the range 54.3 plus or minus 3.2. False. That's a probability question. And we're doing confidence interval. So saying I'm 95% confident is different from saying I will be right 95% of the time, which is weird, but that's how it is. Let me see how they describe it. They probably will say better than I did. All right. 6, is this C? D. If you view the interval as fixed, the chance is either 0 or 1. Oh, that's a great way to describe it. Okay. So 54.3 plus or minus 3.2. Okay. What is the chance that this is correct? This is a much better way to describe it. Or, so my confidence interval is either right or wrong, right? So it's either 100% or 0. How do I know? I don't know. Which is why I say I am 95% confident. Now, if 100 of us do this, 95 of us will probably be right, and 5% of us will be wrong. But my confidence interval is either right or wrong. So you can't say I have a 95% chance of being right. I guess before you take the sample you can, right? But then you don't have the percentages, so you don't have the numbers, so it ends up not working anyway. But the probability of this being right is 0 or 1, 100%. So a confidence interval just means how confident am I that my answer is correct? 95%. Okay. 7. If another survey organization takes a simple random sample, there is a 95% chance that the percentage of Democrats in their sample will be between 54.3 and 3.2. What does that mean? Well, this is my confidence interval. Okay. Megan says, I'm going to do my own. So Megan's sample percentage is going to be some unknown number. It will be hopefully close to 54.3. Okay. Is there a 95% chance that her value will land in this area? So what does my confidence interval do? Mine describes what I think is in the box. Megan is going to sample out of the same box. Will her sample percentage, does it have a 95% chance to land inside my confidence interval? Now, I know what I would say, but I'm not very good at probabilities, so I'm going to look it up. And then I'm going to tell you that I knew exactly what the answer was. All right, 20. Oh my goodness. 24. I'm getting there. And, oh good. I was going to say false, and I'm right. So my confidence interval talks about how confident I am that I captured the true percentage. Okay. My sample doesn't have anything to do with Megan's sample. Right? The only way my sample is going to be a 95% is for Megan's sample is if I ended up getting exactly the correct sample percentage. But can I guarantee that my sample percentage is correct? No. That's why I have a confidence interval. So the answer is false.